G'day and welcome back to Unimig. Today we're going to give you the ultimate guide to MIG welding, but enough chatter, so let's get started. Before you start, there'll be a few influencing factors that will determine what's the best type of welding for you, such as how big the job is. Are you welding indoors or outdoors? How thick is the metal you want to weld, and what's your budget? First, let's answer the question, what is MIG welding? The complicated answer is MIG stands for metal inert gas welding, and is an arc welding process in which a solid wire, the fill metal, is continuously fed through the welding machine and into the weld pool that's created by the arc to form a weld. In simple terms, you burn a roll of wire into a joint using this torch, creating a solid weld. We'll show you how to do that a little bit later. Don't forget that safety is our #1 priority. You're dealing with electrical currents, burning metal, hot welds and bright arc. So make sure you've got the appropriate safety gear before you start. This will include a welding helmet, a pair of heavy duty MIG welding gloves. Make sure not to use TIG gloves as your hands will overheat, and a welding jacket. It's also a good idea if you're working in an indoor environment to use a respirator like this one to reduce inhaling welding fumes. We're going to break down MIG into 4 main categories for the best explanation. These are what you need to start MIG welding, machine setup, how to MIG weld, and extra accessories. Starting with what you need to MIG weld. This can vary due to the job you have at hand. Firstly, you'll need a MIG welder. This is our Unimig 185, and it can MIG weld up to 10mm thick metal seamlessly. Nearly all our machines come with everything you need to get welding, with a couple of exceptions, the main one being gas. So now you have your machine and your safety gear, and now you have to decide what kind of MIG welding you want to do, either gas or gasless. The first and most common is with gas. The gas is used to shield the weld metal from any outside contaminants when welding. However, it's limited to a controlled environment since the wind can blow the gas away. The second is gasless, with the fill metal used having a flux core which protects the weld instead of gas. This can leave a less desirable weld, however it can be used in any circumstance. Depending on which one you choose, you will either need a gas bottle with solid MIG wire, stainless wire, or just a roll of gasless wire to put into your machine. These wires come in many different thicknesses, with the thicker the wire relating to the thickness of the metal you're welding. We usually recommend 0.8 to 0.9 for a machine this size. And now we'll move on to the machine setup. Starting off, let's plug our machine in and turn it on. Next, we'll plug in our torch and earth lead and polarity cable. If you're using gas, you'll need an electrode positive connection with your polarity cable in the positive panel mount and the earth clamp in the negative panel mount. This flips to an electrode negative if you are using gasless wire, and will need the polarity cable in the negative panel mount and the earth clamp in the positive panel mount. And now it's time to set up your wire. Firstly, you'll need a roller that's going to suit the wire size you're using. Mild steel and stainless steel use a V-groove roller. Gasless wire uses a F-groove roller, and aluminium uses a U-groove roller. But more on this one later. We're using a 0.8 mild steel wire, so making sure to use the right size and right groove, slide it in place and screw it on. So now it's time to mount your spool onto your spool holder. Feed it through the wire drive mechanism. Inch it or pull the trigger so it feeds through the lead and it comes out the top of your gun. Cut off the excess using a pair of side cutters. If you're using solid MIG wire or stainless, you'll need to connect your machine to a gas bottle. For MIG, the gas to use is an argon CO2 mixture. To connect, attach the gas hose to the back of the machine and screw the other end into the regulator that's connected to the gas bottle. These are both supplied with the machine. Now turn your gas on to about 8 to 12 litres per minute, which is perfect for MIG welding. All you have left to do is to set your wire speed and voltage. For ease of use, you will find this guide on the inside of our machines. Following this makes for an easy starting point, and you can slightly adjust them to suit your own preferences. So we are welding 6mm thick mild steel flat bar with 0.8 wire. So we will use 23 volts and 12 for the wire speed. One last point before welding is to make sure that your metal is prepared and ready for welding. The easiest way to do this is to use a wire brush or a grinder so you can remove most of the mill scale and the rust. Then attach your earth clamp to your workpiece. All that's left to do is to start welding. There are 3 main factors to consider before you start to weld: your work angle, your travel angle and distance, and your travel speed. To make this simple, Always have your torch on a 15-degree angle to the workpiece joint, pushing the torch if welding with gas and dragging the torch if welding with gasless wire. And finally, travel at a speed where the fill metal is melting into the joint firmly. The easiest way to do this is with lots of practice, so grab a couple of scrap pieces of metal and try it for yourself. You should always keep a consistent distance from the weld joint, about a centimetre or so from the shroud to the joint. If not, you can end up with a weld full of contaminants and an uneven appearance, due to the gas not being able to reach the liquefied weld pool. Another easy way to know if you're welding with the wrong technique is sound. While welding like this with the wrong torch angle, the wrong torch distance, and travelling at the wrong speed, your weld will be offbeat and distorted. This will end up in a weld that looks like this. However, if done correctly, with the right speed, settings, welding distance and angle, making sure to follow the joint perfectly, you should end up being able to clean the weld with a wire brush and to have a weld that looks like this. As an example, if we're doing a downhand butt weld, which is a perfect place to start, angle your torch like this. Travel at around this pace, and either push if using gas, or drag if you're using gasless wire. As you can see, after cleaning, this produces a perfect weld. Now let's move on to a horizontal butt weld. Your settings should be very similar to that of a flat butt weld, making sure to angle your torch like this. Travel at around this speed, and either push if using gas or drag if you're using gasless wire. You should end up with a weld that looks like this. With overhead fillet welds, your settings will need to change due to working against gravity. We would suggest dropping your recommended settings 3.5 for the wire speed and volts by 4 for this technique. To do this weld, it's similar to a downhand fillet, making sure to angle your torch like this, travel at around this speed, and push if using gas or drag if you're using gasless wire. You should end up with a weld that looks like this. With a vertical fillet weld, your settings again will need to change slightly to help you solidify the weld faster as it's working against gravity. We would suggest dropping your recommended settings by 6 for the wire speed and 6 for the volts. To do this weld, it's a bit more complicated. Making sure to start at the base, weaving side to side to create a bed to support the rest of the weld. Then moving upwards in a triangular motion, pausing at the sides and punching into the corner. You will now need to do a capping run. Again, starting at the base to build a foundation and working your way up in a weaving motion, pausing slightly at the sides, making sure to keep your weaves tight. You should end up with a weld that looks like this. As a final note, you can only do this technique with gas, as dragging the torch means that you have to start at the top of the section. This is called a vertical down, which is a non-certified weld, which will result in a weak weld with little penetration. So now, let's talk about some optional or needed accessories. The first and most important accessory you'll need is the consumables. These are needed on any MIG torch, obviously changing in shape and size depending on the torch itself. The ones that are used on our MIG torches are a tip holder, nozzle spring, contact tip, and a gas nozzle. To put them on, firstly put the spring onto the tip holder, screw that into your swan neck, followed by screwing your tip into the tip holder, and then attaching your gas nozzle. The most common to wear out and need cleaning is the contact tip and the gas nozzle. The easiest way to do this is by using a pair of MIG pliers to clean out the inside of the nozzle, also to cut off the burnt wire at the end of the tip. Make sure again to replace these when they are overused for consistent welding performance. So now let's talk about liners. The liner guides the wire from the spool to the gun to assist in the flawless feed. When you change the thickness of your wire or wire itself, for example 0.8 to 0.9mm, you will need to change your liner. We're using 0.8mm solid MIG wire, so we have to use a blue steel liner. To change them, however, you need to follow these few easy steps. Unplug your torch from the machine. Unscrew the nut on the Euro-connect. Pull out the liner that's inside. Measure the new liner to the existing one and cut the size if need be. Feed the new correct size liner back into the torch hose until it stops. And finally, re-screw the nut. Some more small accessories that are great to have while you're MIG welding are right angle magnets and also anti-spatter spray. Right angle magnets help to keep your job in place while you're tacking. An anti-spatter spray helps to minimise the spatter that's going to be left on your job after welding. The final accessory and the best option for MIG welding aluminium is a spool gun. This was designed because aluminium wire is softer and easier to kink while feeding it through a regular torch. It comes standard with a U-groove roller, which is made for aluminium wire, as mentioned before. To set the spool gun up, you need to firstly install the roller. To access the roller, flip open the protective cover, untighten the tensioner screw and snap back the tensioner arm. To change the roller, insert the supplied spanner underneath the roller and tighten the retaining nut, taking off the roller. To replace, simply insert the desired roller onto the spindle, replace the retaining nut and tighten. Now let's attach the first consumables. Start by putting on the gas distributor and screw on the tip holder, tightening with MIG pliers. To install the wire, unscrew the housing cover and pull back the brake. Feed around 30mm of wire into the inlet tube and place a spool of wire onto the spindle, releasing the brake onto the wire to ensure that it doesn't unravel. Make sure your wire feeds through the inlet on top of the roller and into the following guide tube. Next, clamp the tensioner arm closed and tighten the tensioner to apply just enough pressure so the wire will feed through, not forgetting to replace the housing cover and screw tight. To feed the wire, pull the trigger on the spool gun until the wire comes out of the swan neck. The next step is to screw on the contact tip, tightening with MIG pliers, followed by pushing on the gas nozzle and cutting off the excess wire. Now it's time to weld. There are two controllable parameters on this process. The wire speed control determines how much wire per minute will feed through your gun, while the voltage controls the amount of heat and penetration. These two parameters must work in harmony to get a sufficient weld. As a final note, we get the question a lot. Can you weld aluminium with a normal MIG torch? And the short answer is yes. However, you're more prone to kinks and bird nests due to softer wire. But if you must, make sure you change to a U-groove roller in the machine. Also add a neck spring, new tips, liner and a guide tube, and use a shorter MIG torch. 3 meters is preferred, and try and keep the lead as straight as possible when welding. As mentioned before, however, the easiest option and the best option is to use a spool gun. Thanks for watching our ultimate MIG welding guide. If you like what you saw, don't forget to like the video, and we'll see you next time.